What makes Swift a safe language? You may have some questions at this point. How is Swift a safe language? What are the features that make it modern? And does it make my development and apps faster? Answering these questions is the focus of the rest of this chapter. I'll walk you through some of the language and tooling features that have made it possible to achieve Swift's goals. Some types of unsafe code are impossible. One of the biggest selling points of Swift is the safety it gives you while you're developing applications for iOS or Mac. Thanks to the choices made while designing the language, and a smart and strict, without being overbearing, compiler, Swift removes entire categories of erroneous code by making them result in compile time errors. The number of crashes in iOS applications has been greatly reduced since iOS was opened up as a platform for developers. In the beginning, it had all kinds of issues. One of the most common was related to memory management. The exe bad access error code, which caused applications to crash because they tried to access something that was no longer in memory. In the last few years, there have been enormous improvements in the tooling, the platform, and Objective-C to decrease the number of issues developers were having. Now, with Swift, you don't have to worry about a number of common mistakes and hard-to-catch bugs. One of the goals of Swift was to design a safe language, but what is it trying to save us from? Let's look at some common issues that plague developers using many different kinds of languages. Memory management and memory leaks, data structures containing unexpected data types, uninitialized variables, non-exhaustive switch statements, nil or null working its way into the data, and control flow statements with hanging expressions. All of these issues, except memory management, which is mostly handled automatically with the occasional bit of assistance, are stopped by the compiler. Errors caused by these issues, due to bad code or bad logic, are a thing of the past. Comparing the new and the old. Let's take a look at some comparisons of writing safe code in Objective-C and Swift. This is just a quick look. You'll learn about these safety features in depth throughout the book. A quick scan will show you how much cleaner safe code is in Swift. Here are two examples of code that do exactly the same thing. The first is written in Objective-C, and the second is written in Swift. Both of these code examples declare a variable to start a greeting, and then create a dictionary, a collection of data organized into key-value pairs, that has a name as the key and an age as the value. After that, the code loops over the dictionary and prints to the console an introduction to each person. Strongly typed compiled languages are generally safer than dynamic interpreted languages due to the number of bugs that can be caught at compile time as a result of the type system. Where is the type system in Swift, though? You can see all the type syntax in the Objective-C example, but in the Swift example, there isn't a single mention of a string, an integer, or a dictionary. Swift has a feature called type inference. The Swift compiler can look at the definition of greeting and determine that because it's being assigned to a string, greeting's type is string. You can still define the type of something. In some places, such as function definitions, you're required to do so. But by using type inference where you can, your Swift code becomes less syntax-heavy than many strongly typed languages. You can define exactly what type you want a variable to be, such as saying it should be a string, or that it's an array containing values of the type int. Type inference keeps you safe from bugs like the one in listing 1.4. It safely assumes that if you have an array with only numbers in it, your code won't handle working with the text in a string if one sneaks into the array. Type safety and inference go much further than this, as you'll see throughout this book. Avoiding nil with optionals. Swift introduces a way to avoid the infestation of nil and nil checks in code. It does this through the use of a language feature called optionals. Try to retrieve data from a deeply nested chain of properties that may or may not contain a nil value somewhere along the way. This is an example of optional binding and optional chaining, which are incredibly powerful features. Unlike many other languages, where nil is a value that can appear almost anywhere, in Swift, an optional is a succinct way to model the idea that some functions and properties either will or won't have a value, while everything else is assumed to always have a value by default. The compiler enforces this, meaning it's not something you discover you missed later. The last thing you want to have happen is to find out your code doesn't work once it's on an iOS device you can't access for debugging purposes.